Thank you very, very much for joining the talk this evening. My name is Roisin and I am a Peatlands officer with Ulster Wildlife. I've been working with Ulster Wildlife for nearly 5 years now, doing peatland restoration. And yeah, I've been working mainly up on Culka Mountain and then doing some bits of work around a couple of our raised bog sites that we've been working on as well. So despite the title of the talk, I would say I'm not a botanist by training. I've just picked up some of these facts and points of interest over the past 5 years. So if there is folks on the call this evening that are amateur botanists or experienced botanists, please chime in. There's a wee chat function there. You can add comments and any questions that you have into it. And yeah, would love to hear other people's thoughts on some of the plants that I'm going to present then this afternoon or this evening. So, wee bit of housekeeping then. It'll be a 30-minute talk, give or take, and 30 minutes for question and answers. So just so you know, the talk is being recorded. So we're going to share it with registrants and Ulster Wildlife members as well. So please keep your video switched off if you don't want to be recorded. Everyone's going to be muted during the talk, but we might lift the mute after the talk's finished, just for the question and answer session. Please do ask questions as we go along using the chat facility here. And just so you know, at the end of the talk, there'll be a little feedback pop-up that'll come up. It'll just take a minute to complete, and it really helps us improve our future event offerings. Yeah, and so hope you enjoy the talk. So I just wanted to start off by giving a wee bit of context then on what is a peatland. So they are waterlogged habitats, so they're formed under waterlogged conditions, and these conditions prevent the plants that grow on the surface from fully decomposing. So it's all these partially decomposed plants that build up over time, and that's what forms our peat. And in our bogs here in Ireland and the UK, the main peat forming species is our sphagnum moss. So you'll often hear this plant called the bog builder. And whenever I move on in the presentation, you'll see why that is. It's very specially adapted for its role. In Northern Ireland, we've 3 different types of bogs, or 3 different types of peatlands. So we've got our blanket bogs, our raised bogs, and our fens. So the blanket bogs are those peatland habitats that you see cloaking the uplands here. And they're normally about 3-4 meters deep max. Then we've got our raised bogs that you'll often see dotted around the lowlands. They're lovely dome-shaped bogs, and they can be up to 12 meters deep in some places. Both our blanket bogs and our raised bogs are nutrient poor peatlands, and then we've also got another type of peatland called a fen, and they're slightly different, where the first 2 are fed by rainwater and they're nutrient poor. Our fens are fed by groundwater, and so they would have more nutrients than our raised bogs and our blanket bogs. And these habitats formed between 4,000 and 12,000 years ago. So our blanket bogs are between 4,000 and 7,000 years old. And we have done peat depth surveys in the middle of Tyrone, and we are getting down to about 12 meters in places. So it takes about a year for a millimeter of peat to form. So they're getting 12,000 years worth of peat formation on some of those bogs, which is absolutely incredible. And not surprising then that they are the planet's largest terrestrial carbon store. I think we hear a lot about woodland habitats, but our peatlands are actually twice as effective at storing carbon as our woodland habitats. They store twice as much carbon globally as our any other habitat. The blanket bogs and our raised bogs, as I said, are fed by rainwater, and our blanket bogs in particular, they need about 12,000 or 1,200 millimeters of rain for 235 days a year. So you can imagine the Northern Ireland is pretty well suited for these types of habitats. And globally, the UK and Ireland are particularly important for our cover of blanket bogs. And Northern Ireland itself has 18% of its land cover as peatland, but 80% of it is degraded. So although they're great carbon stores, they're actually net carbon emitters at the moment. So as Ulster Wildlife, I've been doing lots of restoration and conservation works to try and turn that around. So that is a quick overview of what our peatlands are. Why then would we have these peculiar plants living on them? And that is because we've got quite hostile living conditions there. So I chose this picture because I think it makes it look like this beautiful golden place to live. But in actual fact, these habitats are extremely hard to live in. So they're very wet. They've got very waterlogged conditions, and that can cause anoxic conditions. So that's when you get a lack of oxygen. As I said, they're nutrient poor, so they're mainly fed by rainwater, and that's known as being ambotrophic. And they're quite exposed as well. So I've been up on Culka Mountain some days, and I feel I've got all 4 seasons in the one day. So difficult conditions to try and survive and thrive in. Peatlands, if they're healthy, would have a water table within 5 to 10 centimetres of the surface. So when they're in a healthy state, they're nice and wet all of the year. When I'm talking about nutrient poor, that ambotrophic, is Greek, or ambro is Greek word meaning shower of rain, which we get plenty of here in Northern Ireland. So as I said, the bog receives water and therefore its nutrients from the rain. So these are the kind of conditions that our plants are trying to adapt to. So the first one I want to talk about is our bog builder, the sphagnum moth. So these are a funny plant. They're kind of dead and alive at the same time. So the tip there, the very head, is alive at the top, but the bottom is under water some of the times, and it's actually the dead plant material. It's not getting any light and it's partially decaying. So the surface, the tip, is gradually rising up as the bottom is gradually dying. And it's that part that's gradually dying that is being partially decomposed to form our peat. And they are considered a keystone species because they define the entire ecosystem then for other species. And that's because sphagnum can actually make the surrounding conditions more acidic, more wet, and more anoxic. They have certain adaptations to be able to do this then. So the moss efficiently holds water in these cells. They're non-photosynthetic cells. So our plants use photosynthetic cells to get energy from the sun, food from the sun basically. But they have these porous cells that account for about 80% of the plant's stem and leaf volume. And that means that these sphagnum mosses can hold up to 20 times their weight in water. And different species are specialised to different niches within the bog. So you'll get species that are specialised to grow in hummocks, some that grow in pools, some of them will form lawns over the bog. And they're these lovely mosses that you'll see as you walk over. They make like this lovely colourful Persian rug of like a living carpet across the bog. Other adaptations they have, it's called sphagnonic acid, and it's a chemical that they have that protects its cell walls from being degraded by microbes that would normally break down plant material. And then they also have this pectin-like compound. So pectin's the stuff that you put in to make jam. And this substance, it's called sphagnum, and it can suppress microbial activity too by inactivating those enzymes that would normally be used by the microbes to break down the plant material. It's also very good at intercepting and retaining nutrients really efficiently, so it can absorb it directly from its leaves into its cells. And it does this via a process of, so we've got our, for example, your potassium or calcium or magnesium, and when it's exchanged with a hydrogen cation. So one goes in, hydrogen cation goes out. And that process means that it's making its surroundings more acidic, because it's those hydrogen cations that are make things more acidic. So as it's taking in more nutrients better than its surrounding plants, it's also making its environment more acidic and less suitable for other plants to live in. It also produces acids that can inhibit bacterial growth around it, and these again are lowering the growth, or lowering the pH and inhibiting growth of other vascular plants around it. So you can kind of see it's engineering both itself and its environment to be more difficult to degrade by microbes, and then in turn makes it a wee bit more difficult then for other plants to survive in that environment. And it's a war hero. So during the First World War, it used to be collected by Scottish women and children initially, working really long hours in these big horrible wet bogs, and it was collected for use in wound dressings. But by the end of the World War, it was being collected in Ireland, England, Canada, the US. Britain alone was producing 1 million sphagnum dressings a month, and the reason was that it was so good at absorbing blood. Remember I was saying about 20 times its weight. And they actually had preferred species. So Sphagnum papillosum and Sphagnum palustri were the golden children, because they were the ones that absorbed more than any of the other sphagnum species. And they also had antiseptic properties. So remember all of those different compounds that I was talking about, the sphagnum, they actually give the dressings an antiseptic property. And it was so important that, I hope you've had time to read that wee poem. This is from Mrs. A.M. Smith, who worked in the Edinburgh War Dressing Supply, and she wrote a little poem about sphagnum. It was that important to the war effort. The next thing that I want to talk about is our carnivorous plants. We actually have 3 different types of carnivorous plants that we get on our bogs here in Northern Ireland. Carnivorous plants they evolve whenever, they've evolved actually over 10 times. So we've got 800 different species of carnivorous plants worldwide. We get them on bogs because nutrients are in short supply, and carnivorous plants benefits from being able to get nutrient boosts from its prey, particularly nitrogen and phosphorus. You could kind of query then, if nitrogen is so important for plants, all plants need nitrogen, then why do all plants not evolve to be carnivorous? And it's really because to alter your leaf shape to be able to capture and attract prey, you're actually less efficient then at photosynthesis. So the benefits of being carnivorous sometimes are checked by the costs of adapting your leaves, meaning that you're less able to take your nutrients from the sun. So I want to do a quick poll in the chat and see, how much nitrogen do you think that on average our carnivorous plants get from the sun versus their prey? So percentage wise, how much nitrogen do you think that they're getting from the sun versus their prey? Just throw some numbers into the chat and we'll see. Nobody's volunteering themselves. 70. So are we saying this is 70% from the prey? Yes. 12. Okay, varied. Yeah, from the prey. Okay. Prey to sun. Spot on, Melissa. Yeah, 30, 70, prey to sun. So there's been studies done, and they've been able to track this, been able to track the nitrogen and where it's come from in the plants. And yeah, about 30% of it. So not a huge amount, but it's kind of like taking a little protein supplement or a protein shake for a bog plant. One of the issues that we're facing now in our peatlands is that humans are having a big impact on the nitrogen cycle globally. as I said, nutrient poor habitats, so a lot of the species are adapted to these nutrient poor environments. So the vegetation communities that you get there is predetermined by the fact that there's very little nitrogen there. Particularly here in Northern Ireland, we're getting a lot of increased nitrogen on depositing in these habitats from the nitrogen and ammonia, and that's been released mainly from emissions from the agriculture sector and also from the burning of fossil fuels. So some of the stuff that we're doing in Ulster Wildlife is monitoring a lot of these sensitive peatland habitats as part of the Northern Ireland National Ammonia Monitoring Network, and that's been fed into to see how big of an issue this is for our protected sites, in particular our SACs. And then that information then is used to back up some policy decisions to try and deal with this issue. So the ammonia strategy went out there for consultation. If you go on our website, you'll be able to see that Ulster Wildlife's response to that strategy about how we can lessen the impact on this, particularly for our peatland habitats because they're so sensitive to it. So you could see then that carnivorous plants then would it's not a beneficial adaptation then because nitrogen is going to be so much more available in these habitats. The next one, so the first one, sorry, that I wanted to talk about were our sundews. So they get their name because they've got all these lovely sticky droplets that glisten in the sun, and that's where they get their name from. So Charles Darwin studied and drew carnivorous plants for years. He noted their reduced root system and their relationship with these nutrient poor habitats like our peatlands. So you can see a wee quote from him there. I care more about the Dorsera than the origin of all the species in the world. So they took up a lot of his time thinking about it. There's 194 species of these sundews worldwide. We've only got 3 here in Ireland. So we've got our round leaf, our intermediate and our long leafed. The sundews then would mainly be preying on things like our small flies, midges, beetles, ants, sometimes as big as damselflies when you've got a couple of leaves getting stuck at the one time. And they go through about 5 of these different prey species a month. They release a really sweet fragrance to attract the insects, and sometimes the insects can mistake the wee glistens for nectar. Each of the tentacles has a little gland that's covered in a mucilaginous secretion, and that's acidic and it has enzymes in it and it doesn't evaporate. So what you get happening then is this process. Let me see if I can get this to play for you. So this is I'm not gonna play. There we go. So the insect gets trapped and the sundew's tentacle and then the movements of the insects lets out an electrical signal, and this causes other tentacles then to start to bend towards it. So within 3 minutes, there's no escape for this insect. The whole leaf has started to bend over and closes up and it wraps around it. And the prey eventually then dies from either exhaustion or asphyxiation. And this could take up to a day maybe for that to happen. So not the most pleasant end. It's called thigmonasty. And a lot of plants would have it. It's a response of the plant to touch or vibration. It's faster in some species than others. Once the prey has trapped, then the enzymes start to dissolve the insect, and then you're just left with that exoskeleton then. And those little glistening dews then, they're being looked at in medical research because they confuse with live growing mammal cells. You can't really be going around harvesting them from sundews. It would take a very long time, but they're trying to see if they can recreate the properties of it and see if it could be used in wound healing or tissue regeneration. So you often find that with plants. Obviously, the medical field tries to take inspiration from medicines from it. The next one we've got then is our butterworts. it got its name. It actually does have like a greasy sort of buttery feeling, as if somebody's buttered the plant. But it gets its name because people used to think that rubbing the juices from the leaves on the cow's udders would prevent evil or bad butter. There's 3 species here in Ireland. We've got the common one, which is found throughout northwest and central Ireland. We've got the large butterwort. It's mainly found in the southwest, in like Cork and Kerry. And then we've got the small one, and it's a lot less common. And it's quite under threat. You don't really get it in the west of Ireland. So how it works is that the leaf surface are covered in these tiny glistening droplets on top of little stalks, and the insects get trapped on it, and as they move around they get more covered in this mucilage. And as you can see there, the leaves are kind of curled inwards so that the insects also can't just roll off, and then the enzymes then on the surface of the leaves then start to break down and digest the plant, and then the nutrients are absorbed through holes in the leaves, and then all you're left with is the dry husk. So it's quite a brazen plant. Like, it's very open about it. You've got this very open rosette, and if you look at it on the bog, you'll see tens of these little tiny insects that's met its end on its leaves. One of the things about these adaptations is to see how these plants balance pollination by insects with also needing the prey to get a nutrient boost. So 2 things that they do is physical separation. So you'll often see with these carnivorous plants, they have a really big long stalk with the flower on the end of it, and that's just the physical separation so that an insect that's coming to pollinate the flower is not going to get inadvertently trapped in this little basal rosette of deadly leaves. But also the shape and the size. So the flower is quite large and it's got really long nectar spurs. So the types of insects that you would expect to be able to reach into it would have very long tongues. So like your butterflies, moths, bees, and they're less likely if they do come in contact with the leaves to get trapped on it. So you'll find that a lot, even our little sundews have quite long stalks in them as well. And then the last insectivorous plant then to talk about is our bladderworts. So the name derives from these tiny bladders that trap or that are on the feathery leaf stems. These are rootless, free-floating aquatic plants. There's about 230 species worldwide. We've got 4 different species in Ireland here. They're quite hard to tell apart. So the way it works is the bladder traps are about 5 millimeters in diameter, and they've got these little tiny trigger hairs around around the entrance of the bladder. And if a little water flea comes swimming past and activates one of those hairs, you'll get the trap opening and the little flea or whatever it is getting sucked in. Let me see if I get one of them. It's extremely fast, as you can see there, so 15th thousandths of a second, and once it's in that little bladder, then it starts to get digested by those juices, and then it takes about 15 to 35 minutes, and then the husk is then expelled, and then there's little glands within the bladder that remove water from inside the bladder, and that creates the vacuum, and then that resets the trap for the next go again. So those are our 3 types of carnivorous plants. Going to do a quick poll here then to see what adaptation you think our cotton grasses might have for our peatland habitats then. So given what we know about these habitats, what do you think cotton grasses might be using to survive and thrive here? So we've got chemical warfare, nutrient recycling, parasitism. Are they carnivorous? Do they go snorkeling? Are they using water conservation, or are they pollinated by rainwater? Is everyone able to see the wee poll? Yeah. I'll just give it a wee minute here. Eve, is that working for folks?
Yeah, I can see people are voting.
Oh, maybe it's
56%, so give it a minute.
I think mine's is maybe just not uploading then.
Do you want me to give you a result? Let's wait a second.
Let's see. Okay.
Should I end
End
it?
it
Can you
there,
see the...
yeah. I'm not seeing the results. Do you want to read it out? It's not working for me.
Sure.
Just
So I think the majority found nutrient cycling,
yeah.
and then equal between water conservation and pollination with water. And box snorkeling is with 3 people voting it.
Okay, interesting. So it's a mix of the nutrient cycling, the bog snorkeling, and the water conservation. So we'll talk about 2 types of the cotton grasses. So number 1, they're a bit of a confused plant because they're not actually grasses, they're sedges. So our common cotton grass, that's our many-headed cotton grass, Angustifolium, has these little air canals in its roots, and that allows oxygen to pass from the parts of the plant that are sticking out of the water to the submerged roots that can sometimes be buried up to 60 centimeters deep. And that allows the efficient movement of oxygen from the aerated areas down to the waterlogged areas, which you can imagine is extremely important in these waterlogged systems. And so it is kind of like snorkeling, and it's just all about that low resistance exchange of oxygen. One of the things is that they can actually end up being sort of like methane chimneys. So oxygen goes from the air down into the waterlogged parts, but sometimes what can happen is the methane from the waterlogged parts can be transported up out of the cotton grass plants. But the balance in a healthy bog would be that we're still getting more carbon sequestered down in through the capture of CO2 into that peat formation process. We also have a hairtails cotton grass, that's a wee single-headed one. Vaginatum, that's named because a wee tuft looks like the tail of a hare. What this plant does is that it grows in clumps to create a drier environment for itself, which is important when you're in a waterlogged system. But then during the summertime, then when the bogs can sometimes dry out, its adaptation is that its leaves are really long, rolled, needle-like leaves, so reducing its surface area for evaporation then of water in those drier times. They also do nutrient recycling, as many of you mentioned. So you'll see them then turning from that green colour in the summertime to the reddy browny colour in the wintertime, that lovely rusty colour that you'll see across the bog. And that's because the nutrients are being drawn down from the leaves into storage organs for use again in the spring. And then we've got our bone breaker plant. So this is a beautiful little yellow star-shaped flowers on it. You'll see them in July or August time, and then later on in the year they'll have these little spiky nut-like orange fruiting heads on them. And they actually used to be flowered, they actually used to be harvested, both the flowers and the little seed heads, for dyeing, because they are a really, really beautiful colour. Like the cotton grass, they store their nutrients in bulbs underground in the winter time, and that's where the new leaves grow from in the spring. Again, for that adaptation of nutrient storage in these nutrient poor habitats. And they do get pollinated by insects, but they also have the additional adaptation of being able to be pollinated by rainwater, which is perfect in somewhere like Northern Ireland where you get plenty of rain. So just the action of the water droplets flicks the pollen onto the flowers and stalks of other plants. The Latin name for bog asphodel literally translates into bone breaker, and this fairly unassuming plant has acquired this quite deadly name because it was once believed that the livestock that used to graze these plants would get brittle bones, but it's actually because of the calcium poor pastures of peatlands that they're grazing on has caused things like foot rot for the livestock. And then the last one I just wanted to talk about was our louseworts, common lousewort. So these are parasitic, they're actually hemiparasitic. So again, they've kind of got a bad name. It was once thought that livestock eating the plant would acquire lice, hence the name. But it's actually probably likely that it's because there's little snail that lives around the lousewort that would have be associated with the liver fluke cycle. So the little lice then would be or the livestock that are grazing on it would end up acquiring the liver fluke, and whenever they get liver fluke, they're more likely to have lice as well. They're hemiparasitic because they supplement their own resources by connecting their roots to the roots of nearby plants. So they're extracting that water and nutrients from the neighboring plants. So that's kind of all of that's kind of a rundown of all the native adaptations or native species adaptations for these habitats. So I just wanted to do another quick poll then before we move on to the next section quickly. So if I share this one. Okay, is everyone seeing this? And Eve, I'll not be able to see you again, so if you can let me know if people are answering. Thank you. So this one is what you find is the most interesting peculiar peatland plant. So our sphagnum bog builders, the sundews, the butterworts and the bladderworts, our bog snorkeling bog cottons, bone-breaking asphodels, or the parasitic louseworts. So I might end it there.
Yeah, so can you see it now?
Yeah, it's not letting me share for some reason. I don't know what's going on with the polls.
The sundew is the big winner with 7 people out of 18, followed by the sphagnum and butterwort.
Yeah, I love the sundews. They're beautiful little plants. I just wanted to quickly talk about some of the invasive species that we get here, because our native species are obviously adapted and evolved into these habitats. But the invasive species have adaptations that allow them to create these little niches on our peatland habitats and cause havoc as a result. So the first one I want to talk about was our pitcher plant. It was introduced into Ireland in 1906 from Canada in Roscommon actually, and then it's kind of jumped about from there. Insects are attracted to it. It's got this kind of weirdly meaty looking leaf, and it's got little droplets that look like nectar on it. So they're attracted to the leaf and also the nectar droplets. They have kind of like a narcotic effect on the insects. They get into a bit of a stupor and then they slip down into the pitcher plant here because they're very smooth sailed. And then also there's little hairs that go inwards towards the belly of the plant, say. And once the insects slide in, they're not able to get back out again. So once it's in there, it gets digested. Same story for all of the other carnivorous plants. It was actually found that there's a single pitcher plant in an Irish bog, and whenever they looked at the contents, there was over 205 prey items, mainly little mites, but there was also caddisflies and midges and right up to like beetles, parasitic wasps, spiders. So very, very effective at their job. And I guess the main issue with these plants is that they would outcompete other plants. And we've done a lot of work in removing pitcher plants from Peatlands Park in County Tyrone. The big one that everyone's probably heard of is rhododendron. So these guys are a nightmare on our peatlands. We've probably removed hundreds of hectares of them at this stage, and they need repeat treatment over a couple of years, mainly because of how effective they are at spreading seeds. So one seed head could produce, or one flower head could produce 3,000 to 7,000 seeds alone. So you have to keep coming back and treating any of the new saplings that are coming up. Their leaves, flowers and nectar produce toxic chemicals, and that makes rhododendron really unpalatable for herbivores. And they're also quite like rough and tough to eat as well. So that means that they're not getting controlled by our herbivores. those chemicals are also known to cause what's known as mad honey disease or honey intoxication. So if you get bees making honey from the nectar of rhododendron, because of those compounds that are in it, they can cause people to have like cardiac problems and intestinal problems. So it's normally short-lived and you have to probably eat a lot of honey for it to be fatal. But yeah, it's been recorded as far back as like 400 BC. There's also thoughts that they may prevent germination of other plants because of the compounds that they release, and they can inhibit, when plants grow around their roots, they can form symbiotic relationships with fungi. So there's some research into the fact that potentially rhododendron could be inhibiting that relationship and stopping then the new saplings from growing. So as to say, it takes over, it's swallowing up a Scots pine here. We've done a lot of work to remove it, and you can see there that it's devastating to the surface. Like there's absolutely nothing able to grow underneath it. It's just a dead zone. But when we have removed it in area of Peatlands Park, we're getting this lovely alder buckthorn coming back. So that's one of our native species. It's a priority species and one of the species that the site has been designated for. And just by the act of simply removing that rhododendron, we've been able to get those native species back. I'm conscious of time here. All I wanted to say about the kind of work that we've been doing is to try and create those conditions for our peatland plants to survive and thrive again. So they want to be wet. We get in there and we block the drains to raise the water table. So this is just up in Culca Mountain there. Every little green dot is a dam that was put in by the farmer that we trained. So it was over 300 done in total there. This is what it looks like on the ground to put in a peat dam. It's fairly heavy or hairy stuff for a digger driver to be doing. You're just basically sitting up on jelly here. It's nerve-wracking to watch, so it must be extremely nerve-wracking to do. And this is what the end result can look like. So all of these little borrow pits will eventually start to fill in with revegetation and sphagnum. And I just love this image because it looks like we've stitched the bog back together again. And then we also have done a lot of work in erosion control. So as you can see here, we're getting lots and lots of bare peat. Nothing is able to grow on that. It's much more acidic. It's very mobile. The rain and the wind is washing it away. Nothing can take root and take hold in it. So we're not getting any vegetation on these areas, never mind our lovely peatland specialised species. So we did a lot of work up in Lough Atona on Culca Mountain to try and revegetate these areas. And basically what that looks like is reprofiling these really steeply eroding edges. So getting a digger in, grading them down to nice gentle slopes and putting vegetation back over the top of them and stretching them out again. So you wouldn't even know that a digger was there, and that was the same day. Similarly for that one, before and after. And sometimes we have to go in by hand, patch them up again with some vegetation. And then we use these coir rolls then. They're like big, massive mozzarella sticks that we had to helicopter in. And basically the purpose of a coir roll is to intercept the flow of all of that water that's washing over the bare peat and trap all that peat sediment behind to create the nice damp conditions that the peatland plants need to survive. You can get a really quick response. That's before and after. And this can just give you an idea of the scale of the work that we did up here. So you can see all of this lovely submerged bare peat that's just rife for our cotton grasses initially to come in on. So you can see over here, all of that red rusty plants are cotton grass, and normally are pioneers when it comes to revegetation bare areas. And that's what it can look like after. You can see lots of lovely cotton grass coming back in on what was once bare peat. And that's before and afters. You can see even sphagnum growing on top of them, which is a great result. And then we're also trialing the use of wool. So coirs made out of coconut husk that we have to ship in. So we're trialing some local materials now to do the same job. And that's it, folks, then. I hope you enjoyed that, and I'd just invite any questions. Maybe if you can put them in the chat, or you can feel free to unmute yourself and ask away. We've got about 20 minutes here for questions. I'll give everyone a wee minute here. Thank you very much, Fiona. Thank you very much, Jane. Do we have any botanists or anything on here, or does anyone want to share even any plants that they find interesting or any adaptations that they find interesting? So what is the chance of repairing the degraded 80% of peatland you mentioned at the start? Look, it's definitely come to the fore a lot in recent years. We had the Peatland strategy that went out for consultation there. I think it was last year or the year before. It's kind of just been halted because we don't have the executive up at the minute. But it's definitely something that there looks to be a lot more investment in. And we're hoping to see changes in some of the agri-environment schemes too, to see if there's ways of managing the grazing on some of these areas, particularly on the commonages. We would see a lot of the damage actually happening on the commonages, and that's just because it can be kind of difficult to incentivise the right type of grazing in those areas through current agri-environment schemes. It's a big task. Like I'm not going to lie, 80% is a lot, but there's a lot that can be done, and there's a lot that has and is being done. And there's a lot of folks working on it as well. It's going to take, I don't think we'll be doing it in the next decade or the next couple of decades. Some of the stuff that we're trying to do in Ulster Wildlife now is map the area of peatland and the condition of peatland across the whole of Northern Ireland, so that we can prioritise where to get in and start doing the work now, because one of the big issues that we're facing is also climate change. So changing in our climate is going to change the conditions of how much rain that we're getting, and that will change what the percentage of our bogs that are actually able to be peat forming. So the big thing that we need to do is get in there before climate changes so much that these areas are past the point of restoration. So it's a really important piece of work that we're doing also. I think all 80% will be a difficult one to hit, but I do think there's a hell of a lot that can be done, and there's definitely a lot of will there and a lot of great people working in this sector as well. Are we doing anything to discourage peat use for gardening? So you would notice, well, the Wildlife Trust movement do a lot. There's campaigns coming up now in the next few months around discouraging the use of peat mosses in gardens. So they're going to be looking at things around how to so people know where to go and get peat-free compost, and do a lot of awareness raising campaigns as well. It's something that we're definitely looking at in Ulster Wildlife too. We've had meetings about it over the last few weeks as well. And I think a lot of it is awareness raising. I don't think a lot of people actually realise the damage that the peat moss that they're using to grow their lovely flowers in the garden is actually having on these fantastic native habitats. And I think that's a big obstacle to overcome. And I know the bans are coming into play over in England and Wales shortly, and it would be great to see similar happening here in Northern Ireland. So Melissa's saying, I may have missed this in the first 5 minutes, but how much of Ireland is peat bog and how much was it? So the stat that I give was 18% in Northern Ireland, and 80% of that is degraded. So that's across raised bogs and blanket bogs. I'm not sure, Melissa, what the whole of Ireland figure is, but I'd say it's fairly similar to the Northern Ireland figure I give. Mainly a lot of it would be drainage, peat cutting, overgrazing on our upland areas, which would cause the erosion that I was showing you. as well as forestry over peat as well would be a big issue. But thankfully a lot's changing in that space as well. Really interested and learned so much. Thank you so much, Judy. Ashley, that's lovely. Thank you very much. James said, are dry and wet heaths considered peatland habitats? And is bladderwort found more so in the bog pools? So I'll answer those first two first. So a peatland is considered anything over, generally considered anything over 50 centimetres. Some places would say over 30 centimetres. So even in some of the areas that we were doing habitat mapping for, on the surface, it might not have looked like a bog, a blanket bog habitat. But if we did a peat depth and it was above 50 centimetres, we would have been saying that that was potentially degraded blanket bog. So that's generally the marker that people would use for that, James. Bladderwort would be, it's a floating aquatic plant, so you would get it in our bog pools mainly. And finally, which of the species mentioned would be more characteristic of raised bog compared to blanket bog? It's a really good question. Let me see which ones I mentioned. So the likes of your asphodels, that would be more of a blanket bog species. What else would be more blanket bog? Your cotton grasses, you would kind of get on both. What other ones did I mention? Your sundews, I think you can see those on both, definitely. Mainly just be the asphodel, I think, that I mentioned. That would be, I'm trying to think about the bladderworts. Bladderworts, we've seen them on raised bogs, and now the butterwort I've only ever seen up on blanket bogs, but I'd be interested if other people have seen them on raised bogs as well. Yeah, anybody else knows, like pop that in the chat. I can only go what I've seen on the ground. Grant, that's me through all the questions. Does anyone have any more then before I jump on or jump off here? No, we're happy enough. Yeah, I would be so interested to do a boggy field trip. Rona, I might actually talk to the comms team and see if we can get out and do one. Yeah, somewhere like Peatlands or Culca would be brilliant because you could see lots of different types of restoration work that have been done in a really small space. So I will definitely mention that to our membership folks and see if we can get one organised for sure. Just before you go, folks, I just wanted to finish by saying a massive, massive thank you for attending today and for all the continued support that that our membership provides us to be able to do the work, like all of the peatland restoration work that we've shown you there this evening. I'd really encourage you to have a look at the other events that are coming up. So we've got a red kite tour coming up. Ronald, I'm sure you've seen lots of his photographs on our Twitter page. We'll be doing a really great talk about wildlife photography. Then we'll have one on rewilding Belfast Black Mountain, another red kite tour in case you can't get to the one in March, and then there'll be a beautiful coastal wildlife walk at the end of April too. So yeah, please have a wee look at those and sign up, and I will definitely get on organising a wee boggy field trip for everybody too. Thank you so much, folks, and yeah, hope to see you at some of the other talks in the future as well, and maybe a wee boggy outing too.